Good afternoon to you. Forgive me my ignorance. I'm not at all skilled in certification activities. I am an enthusiastic general aviation pilot for many years, and I'm working in EASA in a completely different domain than what this workshop normally is about. Nevertheless, I was invited, thank you Carla for this opportunity, to present to you an idea, a concept that we have and on which we are currently working, which is part of the agency's General Aviation Roadmap. I'm taller than expected. I don't hear that very often. Okay. So I am here with skilled supporters, Hette and Bodewin, who are much more familiar with the technical details and acronyms of what you are going to see in a few moments. I am somewhat only a secretary, but I'm trying to capture and coordinate and steer thoughts and ideas and to funnel them into a certain direction so that hopefully this T4S initiative, the Technology for Safety initiative, will bear fruits and will see the light of day rather soon. I think you're going to start with this one, right? Okay.
Okay, thank you, Sasha, for starting off this presentation. I'll put it in perspective. I'm, as was explained, the GA Roadmap Project Manager, and therefore I thought it was appropriate to first of all give you a starting point from my perspective, and then I'll hand over to Sasha, who we tricked into being the chair of this initiative. As he said, it's not his environment at all, but since he's a pilot, it really helps to get the perspective from the end user. So that's what we try to do in the GA Roadmap. Get to results and get into something that the end user will see. But first of all, let me show. Please ignore me. I will ignore you. But let me show how this initiative is part of the GA Roadmap. The GA Roadmap actually is a project that has been running for about 5 years, and we're aiming for, and that was the initial big banner on the GA Roadmap, for lighter, simpler and better rules for GA. And we've been working on changes to regulations, and in the background you see a poster that we publish every year at Aero that gives the progress of all the activities within the GA Roadmap, really aiming at rule changes. I'm a rulemaking officer, so I feel very happy with changing rules. However, we realize that changing rules is not the real best way forward for all issues. So more recently we started doing safety promotion, those kind of things, not focused just on rulemaking. And in that respect also we started with this initiative because we realized that we were looking back at problems in our rules. We did a kind of a patch repair on our regulatory system. But we also identified potential things that will come up in the future that will help the development of GA. And this is where we said, okay, we need to look further than just rulemaking and getting the rules in place. We need to look at what's coming and what we are going to face in the near future. And this is why we started this initiative, Technology for Safety, looking into what is coming to our doorstep and how can we make best use of that. We've seen several examples before we did any rulemaking that changed the safety level in GA. That woke us up saying, guys, there is something happening out there. We didn't change any regulation, but it is having an impact on safety. An example is, for instance, in the US, the safety data for GA showed controlled flight into terrain was one of the main reasons for accidents. And at a certain point in time, it started to go down. Although they didn't change any rules, they didn't mandate any equipment, and still it showed that there was something happening out there. And this is a typical example where new technology came on board the aircraft, and change the life for the pilots. And this is typically what we should be looking for, what is coming, and this is where I hand it over to Sasha. We are looking into possibilities for the future, not just rulemaking.
Cool. Thanks, Bodewin. So, a typical Cessna 172, everyone is aware of how this machine looks like, has been unchanged literally for the last, 50 years, around that time. The fuel quantity indicators are as reliable as, I don't know, you could, shoot stars would probably be a comparison to GPS position and shooting stars. Yeah? This would be probably a good comparison. But still, we have our dipsticks and we know about these issues. But still, people flying these machines die because they stall, for example. Loss of control is one of the major killers in GA. And this is nothing new. But what is new is that we probably now would be in a better position with the technology that we have and the digital stuff that is around in consumer electronics, affordable hardware, stuff that can also be used to enhance safety. So that was the starting point. Looking at the causes, the main causes for GA accidents, what can we possibly do at EASA as a regulator in order to facilitate that these legacy aircraft, in particular, the old aircraft that are still massively being used for training purposes, for example, across our member states, what can we do to foster that even in those old machines that have a very low residual value, so people are not happy to invest disproportionate amounts of money. It has to be affordable, and in order to be affordable, we also have to look at the certification dimension. So what can we do? What types of technologies do we currently have? What can we identify? Like a bit of a think tank. So that initiative could probably best be described as a kind of a think tank for general aviation, modern technologies. An example, we know and we accept that people are flying a lot with iPads and tablets, even iPhones for navigation purposes. It helped to reduce airspace infringements a lot, as an example. So there is a safety benefit. It comes with certain hazards, probably. For example, if you encounter turbulence, you don't want to have this tablet PC flying around in your cockpit, so you better make sure it's fixed. So we approached this topic from a very similar angle, actually, and that is one that we termed the net safety benefit approach. So rather than saying nothing must be installed in an aircraft unless it has been demonstrated under all conditions that it does not create harm, why don't we look from the other side of the story? Why shouldn't we allow new things to be used and installed in aircraft for as long as there is no evidence that it produces harm? Okay, so what's the net safety benefit compared to the residual risk after mitigation? That's the idea. And with this thought, we started off and we composed a group, and that group has been nominated. It has met, I think, 4 or 5 times by now. It is composed of industry experts from aircraft manufacturers, from an avionics manufacturer, and it is also composed of people from the operators domain, like an association, Airsports Europe here in that case, and certain people from inside EASA. And we can, of course, complement this group on demand should we need a certain skill or expertise. There is, in the third bullet that you can see, where we mention the FAA's initiative, which is called NORC, for non-required safety-enhancing equipment. We felt a bit inspired by this, but at the same time we thought it might be a bit too restrictive and too limiting. So our idea is, whilst making use of these principles, maybe to broaden the scope a little bit and be not restrictive in the first place. Here are some examples of what is out there in the market and what would really help, potentially, when it is used by trained and knowledgeable pilots and operators to help preventing bad things from happening. So we have a new generation of low-cost digital autopilots now out. We have simple, affordable angle of attack indicators. In the area of traffic awareness and collision avoidance, we have all kinds of systems now out in the market, and ADS-B out and in is one prominent example that is currently being discussed. We still have people dying because of bad weather encounter, so loss of ground sight, for example, loss of control. Because we don't know about the weather situation whilst being in flight, still. So with this ADS-B in and out, for example, this could come with an additional benefit of data link. Could be even an incentive for pilots to not only have this traffic awareness, but also to have this data link function. Why they might feel more encouraged for a volunteering equipage. So these are all examples that are already available. And as I've mentioned before, our leading principle was to define or to scope a new concept, a new regime in terms of certification that balances more than before the risks and the safety benefits. In former times, until now, in that area, or traditionally, we have predominantly looked into the risk side of the coin, but not so much into the safety benefits of new technology. And for this particular light end of general aviation, and we need to be careful here in framing this, because general aviation, as we know, can be very wide, we are looking at the light end for personal and instructional use mainly, up to a certain mass limit of, let's say, 2,300 and a bit of kilograms aircraft mass. So in line with the applicability of the new envisaged Part M Light. The deliverable of our group ultimately is intended to consist of guidance material that we promulgate to our internal colleagues, the PCMs, experts and the managers, but also externally to industry. It should come along probably with a certification memorandum, which will undergo prior consultation. And it will be accompanied, of course, with supporting material for training purposes so that people are knowledgeable about the limitations, for example, when installing a traffic awareness device. What can I see with this device? And maybe more importantly, what can I not see with this device? Does the airliner see me with what I have installed, with my little flarm, let's say, or with something else, and vice versa, or not? And we have the understanding that this knowledge needs to be enhanced in the pilot community with regard to the capabilities, but also the limitations. So hence the safety promotion aspect and the training aspect is something very important, which has to come along with this facilitation of new technology. Because new technology alone can also introduce new risks and distraction in the cockpit. Okay? And of course, what we do not want is that people only look at their tablets and nevertheless continue crashing because they forget looking outside of the window instead. Now, there is one example where a similar approach, and I'm talking under the control of my colleagues now, has been done, and that is the Garmin G5. And maybe Hette, can I invite you maybe to introduce the Garmin G5 story? And yes, I do. Thank you for volunteering.
Yeah, the Garmin G5. A while ago, we were approached by Garmin and by others as well, where they designed this piece of equipment, which in essence is a, well, if you look at it, a small PFD. And their argument is it's better to have this one installed than the very unreliable vacuum-driven attitude indicators. But the problem was there is no ETSO authorization for this. It wasn't designed to ED12 or DO178. And instead, they applied an ASTM standard, which in fact is really only a standard that verifies the product by testing against the requirements. The standard doesn't define how the requirements are being developed, how they're managed, how you keep configuration control. So there are quite a few issues with this one, but we knew also based on in-service experience that this product was a lot better than whatever it would replace. I'm hoping I'm doing this right. So as I said, the ASTM standard is far from perfect. The absence of a requirement to do solid software design really was an omission. That was one aspect in that standard that we really didn't like. So what we actually did was we sent someone over to Garmin to assess their software design processes. And it turned out that these were not that much different from the DO178 processes. They had an internal quality management or quality assurance system that ensures that whatever software they build, although it's not completely verified and validated against the DO178, it is sufficiently similar. We also knew that it had an excellent in-service record because it was installed in non-certified aircraft previously. We looked at the returns, and that all seemed to be very well. And finally, what we did was we really took some time to look at operational mitigations, which is something that we didn't do in that level of detail previously. So we looked at whatever failure could happen to the equipment, could it actually be mitigated? Can the pilot sense it? Can the pilot sense that there's something wrong? And can he then mitigate the problem? Or if the display goes blank, what other instruments or means does the pilot have? And once we'd done all that and assessed all that, we said, yes, this is something that we need to do in the interest of safety. So in that sense, we approved the AML STC that Garmin applied for. Want me to continue?
Can you take over, Sasha?
Or should I continue? I can continue, no problem. This is what, yeah, indeed. So in essence, this is what we did. Bear in mind, step 2 is something that we always do. Step 2 is your regular 1309 process. We look at the assessment of potential failure conditions. But step 1 is new. We have hardly ever looked at the safety benefits and tried to quantify them and balance them against the 1309 risks. And it's the assessment of the benefits and the scoring of the benefits against the risks, what we do in step 3, that's really, really new here. Obviously, this is something that requires more discussion with the agency, earlier involvement of the agency, and ultimately an agency agreement. We had to agree to the proposed means of compliance that Garmin came up with. And finally, we had to agree on the compliance demonstration, but that's a step that's no different from any regular process that we currently apply. I think this is back to you.
Thanks for chipping in and rescuing me on these technicalities. So, work in progress, I would say. This is at conceptual stage. We are looking ahead at providing our thoughts by means of recommendations into the GA, the larger GA steering committee, from where, hopefully after its endorsement, it can be taken further and it can be further elaborated as to what is needed by the experts in order to make this viable. It should, of course, also in a future step include rotorcraft. So it shouldn't be limited to fixed-wing aircraft. What could be practical applications to illustrate maybe a bit better what this T4S initiative could benefit from in the community? I've mentioned already these fuel quantity indicators. There's a lot of wireless sensors out now. An idea could be, for example, to have a little device somewhere on your leading edge which measures the AOA and which transmit to a little stick shaker that you can put with a Velcro on your steering column. And instinctively, you would like have a little stick shaker function for very affordable little money. The fuel quantity indicator could be supported by highly accurate fuel quantity indicators that are available, for example, from the automotive sector nowadays. Mass-produced articles that could come along also with wireless features. We could look at transparent LED displays, or these OLED displays, which could even be installed in the vision field of the pilot, which is currently, or which until now hasn't been allowed because of not obstructing the pilot's vision. But nowadays we might have transparent glass things like a head-up display in a car, you will know that, where vital flight information can, for example, be displayed right into the side into the line of sight of the pilot. This was available in the commercial sector, head-up displays, etc., but hugely expensive, prohibitively expensive in the light and GA sector. But the technology is now available. It's a means of making it happen and facilitating it from the regulatory perspective. This group is currently busy in trying to identify potential regulatory obstacles and burdens. Not necessarily the group will resolve all of them or will tackle all of them, okay? But the group should come up with, that's the problem, this is a problem definition, and then feed this into those groups, those people who change rules, who deal with these issues for better awareness. So, I think we leave it with this for the moment, and
Yes.
we're happy to take any questions if you have.
Yeah.
If I cannot respond, I'll feel free to write them down and to come back to them later on.
So this is an exciting new change of paradigm, I must say, for EASA. From my point of view, this is something which is, let's say, needing time for us to digest because it's really new. And obviously, we have no questions in Slido about this particular presentation, so you are saved. On top of that, we have not so much time left, and we would like to offer a coffee break, a well-deserved coffee break to the participants before we go to the very last part of the workshop.